Hello there, welcome to Pre-Cal Lecture 1.2. We're going to talk about inequalities in this lecture. So Chapter 1 of Pre-Cal is pretty much all review from prior math classes. So before I get started, if this video helps you out, just please consider buying me a coffee, just a small donation. You can hit the link in the description box or scan this QR code and it'll take you to my Ko-fi website. All right, so inequalities. Let's start out with section 1.2.1, concepts of inequality. So what I'm going to ask is this true? All right, if you have this inequality, 100 greater than or equal to 100. Okay, and then that would mean greater than or equal. So is that true? Well, it is true because it's greater than or equal, and they are equal, so the answer to that is true. How about if you have this, 100 less than or equal to 100? So if we have, that means less than or equal. Of course, the line underneath means the or equal part. Well, they are both equal, so that's also true. Okay, so with this, let's talk about the transitive property. And that's if A is less than B and B is less than C, then A must be less than C. All right, another example would be if A is less than B, then A plus C has to be less than B plus C. So if you add a constant to each one, the same constant, then this will be true. All right, so let's talk about multiplying and dividing inequalities. All right, so if you're in my class, you should be writing all this down on your own paper. As you know, there's a notebook grade where I grade your notes, so make sure you're doing that. So our first example, let's say we have -3 is less than 2. And we want to multiply through, so both sides, by 5. So if you do that, you'd have -3 times 5, and we have less than 2 times 5. So that's going to be -15 is less than 10. So that is still true. Let's try, though, multiplying through by -5. Okay, so if we do that, I would have negative 3 times negative 5 less than 2 times negative 5. So that's positive 15 is less than negative 10. So that's not true. Okay, so that brings us to our inequality rule. And I'll go ahead and write that up here. We're still under section 1.2.1. I'm going to go ahead and give a big asterisk here. Multiplying, or dividing an inequality by a negative flips the sign. All right, so can't forget to do that. Okay, let's move on to another couple of examples of inequalities. This time we'll deal with fractions. So let's say we have 1/5 minus 1/4 is less than, put a little space in between, less than 1/20. Is that true or false? Okay, well, we need to get, in order to deal with this, we need to get a common denominator. So in order to get a common denominator, if you look between 5 and 4 and 20, you do have a common denominator and of those three numbers, and that's 20. So we can just multiply these two fractions by a clever version of 1 in order to get 20 in the denominator. So that would be 4/4, because 4 times 5 is 20. And then 5/5. So that's just, you can multiply anything by 1 and it doesn't change, right? It doesn't really change the fraction. So that would give you 4/20 minus 5/20 is less than 1/20. So that's -1, 4 minus 5, -1/20 is less than 1/20. So, hey, that's true. All right, let's try another one. So in this one, we want to write greater than, less than, or equal. And we have 3/4 minus 1/6, and we're going to leave a blank, or insert a blank, 11/12 minus 2/3. So of 4, 6, 12, and 3, what would be your common denominator there? All right, well, all of those numbers will divide evenly into 12, so we can let 12 be the common denominator. So I need to multiply each of these fractions by a clever version of 1. All right, so for this one, it would be 3/3, because that would 3 times 4 is 12. For this one, it would be 2/2. And then for this one would be 4/4. So if you do that, you have a denominator of 12 with all of them. So that would be 9/12 minus 2/12. And then we have a blank. And then 11 over 12 minus 4 times 2 is 8. So 8 over 12. So now that we have the common denominator, we can subtract the tops or the numerators. We'd have 7 over 12. And then a blank 3 over 12. 11 minus 8 is 3. And so what we're going to put in the blank is this greater than sign. It's not greater than or equal, so I move that out of the way to avoid confusion. But 7/12 is greater than 3/12. So that is your answer. All right, I know this goes, you might not think of this as pre-cal, but you need to be able to deal with fractions and common denominators to work pre-cal problems in the future. So that's why we're going over these things that you may have learned, who knows, even all the way back, some of this stuff to the, say, 5th grade even. All right, let's do one more of those before we go to the next section. So we've got if, so this would be true or false. So if 2x is less than negative 8, then negative 2x is greater than 8. So we want to know, is that true or false? So for this one, we're going to divide both sides. So that we can solve for x, we would divide both sides by 2. So we just want to solve for x. All right, and if we do that, the 2's cancel, and you have x less than, we don't flip the sign, negative 4. Now on this side, we want to divide both sides by negative 2. So if we do divide both sides by negative 2, we would have x and then negative 4. But we're dividing by negative 2, so what do we do with the inequality? We flip the inequality. So they're both, x is less than negative 4, so the answer is true. So don't forget to flip the inequality. All right. So now we'll move on to section 1.2.2. That's inequalities and interval notation. Okay, so let's say we have this inequality, negative 3 is less than x less than or equal to 2. So this, what this is saying is that x can be a range of values between negative 3 and 2. However, because we don't have this line under that inequality, x can't be 3 because it's greater, always greater than 3. And in this case, x can be 2, can be equal to 2. So this sign excludes the endpoint. So the endpoints are negative 3 and 2. Negative 3 is excluded, whereas this sign right here includes the endpoint. All right, so I'm going to show you a couple of different ways to express these inequalities. One we can do with just a number line. So on a number line, we'll put in -3 here. Let's put in a 2 right here. And if the endpoint is allowed, you just put a filled in point. Okay? And if the endpoint is not allowed, so it can be equal to 2, we fill in, but it's an open circle if it can't be equal to. Okay? So let's go ahead and write that. Endpoint not allowed. And then the closed circle is endpoint allowed. Okay, there's another way that you can express. And we'll go ahead and also, because this interval, a lot of times you'll see that it's filled in between. So you kind of do that. So let's show how you can do it another way. -3 here, 2 here. If the endpoint's not allowed, you can use an open parenthesis, just like that. But if it is allowed, we use a bracket, like that. So open parenthesis, not allowed, not part of the interval, and a bracket includes the endpoint. All right, maybe a better way to say this is excludes the endpoint. Okay, so you can use an open or a closed circle, a parenthesis, or a bracket, okay, to signify these intervals. So the interval notation that you would see for this inequality, -3 less than x less than or equal to 2, interval notation is going to be an open parenthesis next to the -3 and a bracket next to the 2. Right? So that's kind of a little faster way to write it than writing the inequality. Okay, let's do some examples of inequalities in interval notation. So our first example is, let's say we have this inequality. 1 is less than or equal to x less than or equal to 10. I want to express that inequality both as an interval and as a number line. All right, so as a number line, I can just write a 1 and a 10. You always go left to right. And since it's both less than or equal to, we would use a closed circle for both. Now, as an inequality, since they're both less than or equal to, we would use a bracket for both 1, 10. So that means both the 1 and the 10 are included in the interval. All right, let's try another one. Let's say we have -3 less than x less than 0. Okay, from a number line standpoint, put a -3, a 0, it would be 2 open circles, wouldn't it? Because neither endpoint is included. We don't have that equal sign there. And as an interval, it would be both parentheses, -3 to 0, but neither endpoint is included. This interval does not include -3 or 0, just everything in between. All right, let's get a little tricky. How about x is greater than or equal to 5? So what that means is that on this interval, the smallest number is 5, because x is greater than or equal to 5. And since it can be equal, it's a closed circle. And we're going all the way, since x is greater, you go all the way to positive infinity. So that's how you would show it on a number line. How would you show it in interval notation? It would be the smallest number is 5, so sometimes it's easy for students. If you go ahead and draw out a number line, you know that 5 has to be on the left. So it's 5, and then you're going to positive infinity. So write the numbers first, and then use the symbols. Well, since it's equal, greater than, or equal to, we would put a bracket around the 5. But the infinity, either negative or positive infinity, always has to be a parenthesis. Okay, you can't bracket infinity, because you can't equal infinity. So whether positive or negative, you can't put a bracket. It's unbracketable. Okay, let's try another one like that. How about x less than -1? So x is always smaller than -1. Well, on our number line, what that means is that we would put our -1 to the right side of the number line, because x is always less than that. Okay? And it's going to be an open circle there, because there's no equal sign there. So an open circle all the way to negative infinity. So if you get mixed up in your head which side goes, do a number line, and the negative infinity goes on the left side of your interval, and then -1 will go on the right side of your interval. You can't bracket infinity, so it has to be parenthesis. And because it's not equal, because it's an open circle, you have to put a parenthesis around the -1 as well. All right. A couple more examples and we'll be finished with this lecture. Okay, let's try going the opposite direction. Let's say we have, we're given an interval, -5 to 2. We have a bracket and a parenthesis. And we want to know what's the inequality. Convert that to an inequality. Well, we'll go ahead. I've been doing the number lines, so we'll go ahead and do a number line real quick. -5, 2. The 2 would be an open circle because it's a bracket, and then the negative, because it's a parenthesis, and the -5 is a bracket, so that's a closed circle. And we know we're in between those two. So our inequality is going to be -5 less than or equal to x less than 2. Okay, the parenthesis tells you less than. The bracket tells you less than or equal to. So the homework asks you to go from interval notation to inequality notation and vice versa. Let's do one last example. Let's say you just have all parentheses 0 to 1. And I won't do a number line on this one. Just what is the inequality? So, you know, it's always got an X in it, right? And it's both parentheses, so they're both going to be less than 0 to 1. Okay, both parentheses, both less than. Now, if you ever see this, negative infinity to infinity, that means any real number. Okay, so the homework that goes with this lecture is your worksheet one point two point one to 1.2.2. All right, so that worksheet looks like this. And you just make sure to show all your work where there is work. There's not a ton of work. For section 1.2.2, you just kind of write the answers out. Okay, but for these with fractions, you need to show your work. And that's all I have for this lecture. And again, if this video helped you out, feel free to help me out a little bit for taking the time to make the video. Click the link in the description box or scan the QR code to make a small donation to my channel. Thank you so much, and I will talk to you next video.